Hi, good evening friends. Welcome back for the engineering drawing subject online presentations for the town planning and building overseers examination to be conducted by the Telangana State Public Service Commission. This is the second day. Yesterday we had some discussions of the subject, like in the introduction component we have discussed about basics of drawing, the difference between different types of drawings like artistic and engineering drawings, and then some instruments, course of practice, lettering and numbering, such things we have seen, you can see here. And now we will be going with, in the course of practice component, certain things related to the dimensioning, and the next we have the construction of plane figures and geometric figures, and then based on the time available we will try some introduction to orthographic projections, and today we will also discuss certain questions, because at the end of the second day something we would be in a position of having covered something. Therefore కొంత వర్క్ అయిపోయి ఉంటుంది కాబట్టి రిలేటెడ్ క్వశ్చన్స్ వీలైనంత వరకు మనం డిస్కస్ చేద్దామండి. రైట్, before I go to the actual subject content, yesterday I was expressing doubt about one particular code number, so that today I am clarifying that generally we do not expect parts with 0. This is one code where the part is 0. So I was just thinking whether there was a print mistake. It's not so, it was correct, and that code is IS 9609 part 0 2001. It's about technical product documentation, lettering part 0, and how to document things, general requirements of documentation. Okay, all these are available in this website, as I told you. Okay, now as per the syllabus, what we have seen so far is what at around 1.5 hours we had a discussion. Now we will continue with the same serial order. So today we will be discussing what construction of closed figures and polygons and some aspects of orthographic projections. Before we go to the dimensions topic, and because yesterday we only had an introduction to dimensioning, ఇప్పుడు ఫర్దర్ డీటెయిలింగ్కి వెళ్దామండి. స్టాండర్డ్ ప్రాక్టీసెస్ పాయింట్ ఆఫ్ వ్యూలో డ్రాయింగ్స్ వేసేటప్పుడు మనము we should have complete command on the కోడల్ ప్రొవిజన్స్. ఆ కోడల్ ప్రొవిజన్స్ యొక్క కమాండ్ మనకి ఎప్పుడు వస్తుందంటే మనం ఏ టాపిక్ డీల్ చేస్తున్నామో ఆ టాపిక్కి సంబంధించి కోడ్ ఏం చెప్తోందో తెలుసుకుంటే అవుతుంది. ఇక్కడ వీఆర్ నౌ అబౌట్ టు డిస్కస్ డైమెన్షనింగ్ ఇన్ డెప్త్. సో డైమెన్షనింగ్ అర్థం చేసుకోవడానికి ప్రాసెస్ అర్థమవుతుంది. అందులో డిఫరెంట్ టైప్స్ ఆఫ్ లైన్స్ వస్తాయి. ఏ లైన్ ఎక్కడ వాడాలో అన్నది ఇంకొకసారి నేను మళ్ళీ చూపిస్తున్నాను. లాస్ట్ క్లాస్లో చెప్పినదే. ఇక్కడ కూడా ఎందుకు ఆగానంటే మనకి బిట్ క్వశ్చన్స్ వీటి మీద వచ్చేటటువంటి అవకాశం ఎక్కువ ఉందండి. స్టాండర్డ్ ప్రాక్టీస్ అనేటటువంటి టాపిక్ కింద మనం కోడ్స్ రిలేటెడ్గా డిస్కస్ చేస్తున్నప్పుడు యూ విల్ హ్యావ్ లాట్ ఆఫ్ స్కోప్ ఇన్ objective questions from this particular topic. Okay, so just where each line is used అన్నది, as I told you, normally when we make a drawing, as I already told you about the visual edges of a particular drawing, something we use continuous thick lines. Okay, and majority of the other lines are thin lines. What are the other lines? When you start drawing, even if you want to draw a straight line, first we'll draw a thin line. On that mark the distance. Is it not so? So majority of the time we'll be drawing only thin lines, because these are the thin lines which will build the sketch. Later on we'll thick it, the required components. Other things can be left over like that if we can manage well. Okay. So thin lines will be used for so many applications like construction lines and edges and dimension and leader lines, hatching, outlines of adjacent parts, outlines of revolved sections. So many examples are there. When we are dealing with number of drawings, we will be coming across those lines. So కాంటెక్చువల్గా మనకి ఆ అవసరం వచ్చినప్పుడు ఆ లైన్ ఎలా వాడతాం మీకు ఆటోమేటిక్గా అప్లై అవుతూ ఉంటుంది. ఓకే, అది. సో కంటిన్యూస్ థిన్ లైన్, లిమిట్స్ ఆఫ్ partial views. So like that, especially as I told you, majority of the times మనం వాడేటటువంటిది కంటిన్యూస్ థిన్ లైన్. అండ్ దెన్ హిడెన్ పార్ట్స్ అన్నీ కూడా మనకి డాష్డ్ లైన్స్లో కనిపిస్తాయి. అలాగే సెంటర్ లైన్స్ కూడా ఎక్కువ వాడుతూ ఉంటాము. ఆ సెంటర్ లైన్ ఎలా ఉంది, ఏంటి తేడా డాష్డ్ లైన్కి సెంటర్ లైన్కి? సెంటర్ లైన్ విల్ బీ విత్ లాంగ్ డాషెస్ అండ్ short dashes like that. Okay, like that. And you can also see the a small difference between these two lines, chain lines. Okay, like that, cutting planes, etc. We use same line for cutting line, but with thickened edges. So this is what. Of course, we don't have sections of solids in our syllabus. If you are drawing sections of solids, you have to represent the section plane by a line, in which case it's same as this line but with thickened edges. That is the section line we call it. Okay, so have continuous, have proper understanding of different lines. Okay. Now what is dimensioning? First of all, what is the dimension? This is how sometimes in the objective questions, if the language is given in a twisted manner, though you know the answer, you cannot properly choose, or it takes more time. మనకు ఒకసారి ఆ లాంగ్వేజ్లో ట్విస్ట్ ఇస్తే, ఆ సెంటెన్సెస్లో చిన్న చిన్న ట్విస్ట్లు పెడితే టైం ఎక్కువ పడేస్తుంది. సో అలాంటప్పుడు మనం ఇబ్బంది పడకూడదు. అంచేత ఏ టాపిక్ తీసుకున్నా ఫస్ట్ దాని డెఫినేషన్ అర్థం చేసుకోండి. దిస్ ఈజ్ మై అడ్వైస్, నాట్ ఓన్లీ దిస్ సబ్జెక్ట్, ఎనీ సబ్జెక్ట్. ఓకే, so what is the dimension? Dimension is an indication of the measure of quantity. Yes, what is my height? So height is the quantity, how I measure it in terms of some feet or meters or centimeters, like that. So if I want to express the height or say length of this object or height of this object or diagonal distance, so to express the quantity we use a size factor, size indicator, that is what you call dimension. And it may be a linear dimension, which is the distance between 2 points, or an angular space, that's an angular dimension. Okay, like that, it may be a linear or angular dimension as explained there. And first of all, what is the need? As we have discussed, engineering drawing లో మనకి డీటెయిలింగ్ ఉండాలి. ఆ డీటెయిలింగ్కి మనకి ఇది ఆ డీటెయిలింగ్లో సైజెస్ అవి మనం చెప్పాలి కాబట్టి వీ నీడ్ దట్ డైమెన్షనింగ్. ఓకే, సో ఎసెన్షియల్ ఫర్ డీటెయిలింగ్. అండ్ సిమిలర్లీ వెన్ యూ వాంట్ టు డిటర్మిన్ ది క్వాంటిటీస్ లైక్ ఎస్టిమేషన్ అది చేసేటప్పుడు డైమెన్షన్స్ లేకపోతే ఎస్టిమేట్ చేయలేం కదండి. ఓకే, ఎస్టిమేషన్ అంటే కాస్ట్ కట్టాల్సి రావచ్చు, కాస్ట్ కట్టాలంటే క్వాంటిటీస్ కట్టాలి, అట్లా అనమాట. సో లైక్ దట్. అండ్ బట్ ఇంకొకటి, అసలు సరిగ్గా డైమెన్షన్స్ లేకపోతే పెద్ద ప్రాబ్లం ఏంటి, వర్క్ ఆగిపోతుందండి. సపోజ్ ఒక వాల్ కడుతున్నారు, ఆ వాల్ కట్టేటప్పుడు ఇక్కడ ఒక స్పేస్ వదలాలి, డోర్కో విండోకో స్పేస్ వదలాలి. ఆ డిస్టెన్స్ మనకి డోర్ సైజ్ ఇచ్చి ఉండొచ్చు, కానీ ఎడ్జ్ కార్నర్ నుంచి ఎంత దూరంలో ఆ డోర్ పెట్టాలి అనే డీటెయిల్ ఇచ్చేటప్పుడు మనం ఆ డైమెన్షన్ మిస్ అయితే వర్క్ ఆగిపోతుంది కదా. అంచేత దీనివల్ల డిలే అయిపోతుంది, లాస్ ఆఫ్ రిసోర్సెస్, డిస్ప్యూట్స్ వస్తాయి, చాలా ఇబ్బందులు అయిపోతాయి. కాబట్టి ఫుల్లీ డైమెన్షన్ డ్రాయింగ్ వేయడం రెస్పాన్సిబిలిటీ ఆఫ్ ది డ్రాఫ్ట్స్మెన్. ఆల్సో చెక్ చేయడం కూడా రెస్పాన్సిబిలిటీ ఆఫ్ ది పర్సన్ హూ ఈస్ రివ్యూయింగ్ ది డ్రాయింగ్ ఆర్ చెకింగ్ ది డ్రాయింగ్. ఓకే, therefore you should have full control over the procedures of dimensioning. So if you want to understand dimensioning, it involves drawing number of lines and putting some values in a particular way so that everybody will understand. For that purpose, what we do, we have to understand what are the elements of this dimensioning. So what are the elements of dimensioning? If you see, there are different elements of dimensioning. So they are, first, dimension lines. Each dimension line will have a terminal at which we may put an arrowhead. If not arrowhead, if you don't have space, we may give a dot or we may give a cross. There are, even the arrowhead may be like this or a closed head like this, all these things. So different ways. Dimension lines go with arrowheads at the ends. Then dimension value, if this length is measured, what is its value? Say 42 millimeters. That value is dimension value. Okay. And then extension line. How you mark the dimension line, I'll explain with you know that just to suit the quick way of thinking while writing the examination, you should know certain wordings so that in the options you can quickly select what is a particular answer like. Okay, so extension lines. So when you are putting the arrowheads, you are putting the arrowheads at the end of the dimension. That is terminals. That point is connected to the object through line which are extended from the object to the line. In the sketch you will see better way, and they are extension lines. So these are the extension lines. Okay, see, these two are the extension lines. These are the extension lines. And then leader lines, unit box, indicators, notations like that. So if some detail is to be given like this, this is called detail. You speak about this object here, you write about the specification, etc. And then this arrowhead at this end. This is called the detail object. This is called detail. So the arrowhead should be pointing towards the object. Object వైపే arrowhead ఉండాలి, detail వైపు description ఉంటుంది. Okay, like that. Then we'll see. Then this, while putting the dimensions for different contexts, there will be different needs of placing the dimensions. For that reason, we have two systems of dimensioning, like unidirectional and aligned system. Both were linear and angular. Okay. Similarly, there will be several types of dimensioning: chain dimensioning, parallel dimensioning, combined dimensioning, progressive dimensioning, equal dimensioning, angular dimensioning, and dimensioning by coordinates, around 7 here. Like that there are. So systems versus types also you should have a complete command, because there may be some options may be given there for you. This is not one of the systems of dimensioning, like that you will write. In the list, he will give all the types except one, like that, or types. In the types, he may put one system, and then he will ask you, this is not a type of dimensioning. So if you don't know because both you study in this chapter, is it not so? రెండు చదువుకుంటాము, కానీ సిస్టమ్ ఏది, డైమెన్షనింగ్ ఏది, టైప్ ఏది అనేది తేడా తెలుసుకోగలిగినప్పుడే ఆన్సర్ క్విక్గా మనం ఇవ్వగలుగుతాం అన్నమాట. అది ఓకే. సిస్టమ్ అనే పేరు ఉంటుంది, టైప్ అని కూడా యాడ్ అయినా చేసినా ఇబ్బంది పడకూడదు, అది నేను. ఓకే, నౌ యూ కెన్ సీ systems and types in detail. We'll go through that. Okay, But what are the rules of dimensioning? Yes, a well-dimensioned drawing will be quickly read and quickly interpreted by the users. కరెక్ట్ పద్ధతిలో మనం డైమెన్షనింగ్ ఇస్తే తొందరగా అర్థం చేసుకుంటారు. మన డ్రాయింగ్కి మనకి కూడా ఒక విలువ ఉంటుంది. అలా ఉండాలంటే మనకి we should follow certain rules. Okay, so what are the rules? All the rules are given in the code, textbooks, etc. But all these rules are for the benefit of all the stakeholders. They are based on what? They are based on these again certain principles. So most important for achieving good dimensioning, you need to have to achieve these things like legibility, uniformity and conformity with the code of practice. That is SP 46 speaks about all these things. So we'll see what are those things. Okay, so this one sketch gives you the examples of all these things, right? You please observe this sketch for a while. Please observe the sketch clearly for a while. Right. So what are these things? You can see what are the dimension lines. Any dimension lines ఉన్నాయి ఇందులో అండి. ఎన్ని డైమెన్షన్ లైన్స్ ఉన్నాయి, ఎన్ని యారో హెడ్స్ ఉన్నాయి, ఎన్ని డైమెన్షన్ వాల్యూస్ ఉన్నాయి, ఎన్ని ఎక్స్టెన్షన్ లైన్స్ ఉన్నాయి అన్నది మనం ఆలోచిస్తే తొందరగా చెప్పగలుగుతాం. ఎస్, దిస్ ఈజ్ వన్ డైమెన్షన్ లైన్. ఈజ్ ఇట్ నాట్ సో? ఈజ్ దెర్ ఎనీ అదర్ డైమెన్షన్ లైన్? Yes, there should be some more dimension lines, but for example we have gone only. So there is one dimension line here. Okay, అన్ని యారో హెడ్స్ ఉన్నాయి. ఎస్, ఈ డైమెన్షన్ లైన్కి ఒక డైమెన్షన్ లైన్ ఉందంటే రెండు ఉంటాయి. ఆ తర్వాత ఇవి లీడర్ లైన్స్ కదా. దీస్ ఆర్ వాట్? లీడర్ లైన్స్ విచ్ లీడ్ ది డీటెయిల్ టు దాట్. అదనమాట. సో 1 2 3 4 5 లీడర్ లైన్స్ ఉన్నాయి. ఈచ్ లీడర్ లైన్ విల్ హ్యావ్ one arrowhead. So 5 plus these 2. So how many arrowheads we have? 5 plus 2, 7, right? 7 arrowheads. And dimension values, only one dimension line, hence only one value we can have it. You can see, right? Only one value we have. Dimension value ఒకటి కనిపిస్తుంది ఇక్కడ. ఎక్స్టెన్షన్ లైన్స్ ఎన్ని ఉన్నాయి? ఒక డైమెన్షన్ లైన్ ఉంటే దాని ఎండ్లో వచ్చేదే మనకి ఎక్స్టెన్షన్ లైన్స్. These are the extension lines. Okay, there are 2 extension lines in this example. And how many leader lines? Just now we have seen 1 2 3 4. There are 5 leader lines. Okay, and then units box. There is one unit box. This is what I was telling you yesterday in the introduction. We will not repeat the dimensions. All dimensions should be in one common units only. Therefore we will show that unit in the box. Okay, that is the dimensions box. Okay, see all dimensions in millimeters. Is it not so? Okay, all dimensions in millimeters. This is called unit box. Okay, and then in the next drawing I will show you the other examples of indicators, wherein simply instead of putting so many details we will give certain notations. ఆ నోటేషన్స్ ఇవ్వడం వల్ల అది రేడియస్ అని, ఆ సర్ఫేస్ ఒక స్క్వేర్ షేప్లో ఉందా, లేకపోతే స్పెరికల్ షేప్లో ఉందా, సిలిండ్రికల్ షేప్లో ఉందా, ఇలాంటి విషయాలు, ఆ రేడియస్, ఆ డయామీటర్, ఇలాంటి విషయాలు చెప్పడం కోసం వాడి సింబల్స్ని ఇండికేటర్స్ అంటాము. అండ్ మోస్ట్ ఆఫెన్ ఆస్క్డ్ క్వశ్చన్, వాట్ ఈస్ దట్? ఇంపార్టెన్స్ ఆఫ్ ది arrowhead. Okay, the length of the arrowhead should be 3 times the width of the arrowhead. L is equal to 3W. So this is most often, you all know this, but real difficulty for many of you will be in ability to draw like that. Here I am just showing on the same sketch. Many students complain that, sir, I am not getting like that. So the best way is just don't end the arrowhead here. End the arrowhead a little bit away. And then try to take it like this. then you will be able to get lengthy arrowheads. So number of times students will be complaining just like this. They could not follow. So for that, the best way is, don't try to end the arrow here, but then later on connect. A little bit away from the extension line if you start, then you will be able to solve the problem. This is one technique. Okay. Anyway, now this is what arrowheads. There are different types of arrowheads for different contexts again. You can see arrowheads and positionings of a dimensional line. How you have to position the dimension. These are all the rules of dimensioning. ఏంటి డైమెన్షనింగ్ వేసేటప్పుడు మనం ఏ రూల్స్ ఫాలో అవ్వాలి అని చెప్పేదే ఇది. ఏంటి ఆ రూల్స్? యూ కెన్ సీ, ఒక స్కెచ్కి మరీ దగ్గరగా వేయకూడదు, మరీ దూరంగా వేయకూడదు. ఈజ్ ఇది డైమెన్షనల్ లైన్, దేర్ షుడ్ బి సమ్ గ్యాప్. అది ఈ గ్యాప్ ఎంత? ఈజ్ ఇట్ 6 to 8 mm. Okay, like that there are certain rules. 6 to 10 mm of course here. 6 to 10 mm. Here it is written. Okay, and extension line extends 3 mm approximately beyond the dimension line. For example, see here, these are the two things. You are able to see this, hope. Okay, so this is the object, this is the extension line. The extension line is starting with a visible gap of around 2 millimeters. Similarly, the extension line, where should it go? Beyond the dimension line for a distance of how much? Around 3 millimeters. So we should not draw just like this. You should not end like this. No, little bit more you have to. Similarly, you should not end like that. Similarly, if there is an object like that, you should not connect the extension line with the object. No, there should be a visible gap between the object and the extension line. These are all the rules of dimension. Okay, so and how to place the arrowhead, and its pointed end touches an outline, extension line. Sometimes you may not be able to draw the extension. Sometimes you start the dimension from the object also, sometimes even it is required. So in such situations, without dimension, for example, from this, if I want to show something here beyond this, if I don't have space here to give some dimension here, sometimes I may start, in which case I can as well start from this point itself. Okay, like that. Okay, and then the arrowheads. So what are the types? Open type, closed type, closed and filled type. If there is no space, you will go with a 45 degrees slant line at the intersection of dimension line and the extension line. Even if for a small dimensions like 2 mm, 5 mm like that, you will have to show through dots. You can see it's a small dimensions, you can show through these dots. Okay, like that. So there are several ways of representing dimensions, arrowheads, etc. Now you can see systems and types. First we will discuss on systems of dimensioning, then we will discuss on types of dimensioning. What are the systems of dimensioning? Okay, what are the systems of dimensioning? The way in which you place the values, there are two ways you can put. What are those two ways? You can give a break in the dimension line and put the value, or you can directly put the value on the dimension line. Accordingly, we have systems. If you put a break and put it in the middle, it is called unidirectional system. If you put it on the line, it is called aligned system, because in these two cases, it is not just these two, but whatever is the direction of the dimension line, still always we put horizontal way. The fonts are written horizontally always. ఆల్వేస్ హారిజాంటల్గానే మనం ఇస్తాం అనమాట. అది యూని డైరెక్షన్, దాని పేరే చెప్తాం చూడండి, యూని డైరెక్షన్. సో the dimension is kept always left to right, whether it is a vertical dimension line or a horizontal dimension line or an inclined dimension line. The dimension is put always in a రూళ్ళ మీద ఎలా రాసుకుంటాము మనం, హారిజాంటల్గానే రాస్తాము. అది యూనిడైరెక్షనల్ సిస్టమ్. దట్ నేమ్ ఇట్ సెల్ఫ్ ఈస్ టెల్లింగ్, ఓకే, యూనిడైరెక్షనల్. అదర్ సిస్టమ్ ఈస్ aligned system. What is this aligned? It is aligned along the line. అంటే డైమెన్షన్ లైన్ హారిజాంటల్గా ఉంటే ఇక హారిజాంటల్గా ఇస్తాం, డైమెన్షన్ లైన్ వర్టికల్గా ఉంటే ఇలా వర్టికల్గా ఇస్తాం. వర్టికల్గా ఇస్తాం. డైమెన్షన్ లైన్ డైరెక్షన్ ఇలా ఉంటే, డైమెన్షన్ లైన్ డైరెక్షన్ ఇలా ఉంటే ఇంక్లైన్డ్గా ఇస్తాం. డైమెన్షన్ లైన్ డైరెక్షన్ ఇలా ఉంటే ఈ విధంగా ఇస్తాం. See, from bottom to top or from left to right if it is in this direction, and bottom to top in this diagonally up direction. If it is down in this angle, that is inclination left of vertical kunte ilaga left top corner nunchi right top corner direction lo right bottom corner direction lo istamu. On this you may have questions, okay, right? So మనం ఎలా ఇస్తున్నాము దాన్ని సెంటెన్స్లో ఎక్స్ప్రెస్ చేసేటప్పుడు ఎలా ఆన్సర్ చేయాలన్నది గుర్తుపెట్టుకోండి. సో వాట్ ఆర్ దే? ఇఫ్ ఇట్స్ ఏ వర్టికల్ వన్, బాటమ్ టు టాప్ ఈ డైరెక్షన్లో వేస్తాం డైమెన్షన్ లైన్ని. ఇఫ్ ఇట్ ఈస్ అన్ ఇంక్లైన్డ్ వన్ టు ది రైట్ ఆఫ్ వర్టికల్, ఫ్రమ్ లెఫ్ట్ బాటమ్ కార్నర్ టు రైట్ టాప్ కార్నర్ డైరెక్షన్లో డైమెన్షన్ వేస్తాము. చూడండి, ఈ డైరెక్షన్లో వేస్తున్నాం కదా, రాస్తున్నాం కదా, ఇలా రాస్తున్నాం కదా. అలాగే ఇఫ్ ది ఇంక్లినేషన్ ఈజ్ టు ది left of vertical, then you write like this, that is from top left corner to bottom right corner. If it is a horizontal one, directly put it on this. That is the aligned system. Aligned means what? It is along. That is the meaning. Now the examples you can see here. See, aligned and unidirectional. You can see this. See, placement or disposition, okay, in the unidirectional system, how many dimensions are there? 20. Vertical line but horizontally written, horizontal, even vertical line 15, vertical line 40. All these figures you see, two things you have to observe in the unidirectional system. One thing is the fonts are always written horizontal, that is one thing. Second thing is the fonts are written or the dimension value figures are written giving a break in the dimension line. That is how you can say, see, break. It is on the line or not above the line. Sometimes people may call on the line but with a break, okay. So see, it is broken and written, whether the line is this way or that way. Similarly, if there is a dimension line to be written here, how we write there? We put and write some value x in that direction, okay. So this is unidirectional. Why it is unidirectional? Always horizontal and then with a break, clear. Then see here, if it is a circle, you put a diameter here. There may be external dimension, internal dimension, that also I will tell you. So even angular also, it is an angle, okay. This angle is measured with a break here, okay. If it is an internally, external, sometimes we don't have space. In that case, we put like this. There are two external lines, dimension lines, and in between you put the value. Even for an angular this thing also, we will put like this. If there is no space here, we put here, okay. That is this thing, okay. And in the aligned system, now you can see what is the way in which it is kept. You can see this is, there are 1, 2, 3, 4 horizontal dimension lines. For them, without break, we kept the values like this, above the lines. Is it not so? Above the lines, no break, no, this is continuously it is drawn. But here you can see there is a vertical line here, there is a vertical line here. In this vertical, from bottom to top, 100. How it is written? Similarly, it is vertical. See, bottom to top it is written. Similarly, for a slant line, as I told you here unidirectional. So, if it is unidirectional, we will put horizontally. Now it is aligned. So, on this, okay, you are able to see, right? On this, you will have above that, in that direction we will put. Same thing if it is unidirectional, how we put that? Horizontally we write with a break. That is the difference between unidirectional and aligned system. This is aligned system, this is unidirectional system. Similarly, the angular value, you see, on that we put. If the same thing, if it is unidirectional, what we put? If some angle has to be written like this, 130 degrees, like that, horizontally we write with a break, that this is unidirectional. So, like that you can see different ways of dimensioning. And if it is an external dimension, so aligned system lo external dimension unte teda entante, external dimension suppose a small distance ikkada meeku itla undi anukondi, we will continue the line itlaga anamata, we will continue the line and put this value, ee value ikkada place unte you write here 2 like this 2, ikkada space lekapothe side lo ade direction lo veyali. This is external dimension. Even angular dimension ki also same way. Here if it is a small angular dimension, you continue the arrow like this and put on that, say 18 degrees like this, on that you put like that. Okay, this is how you can understand the difference between the unidirectional and aligned. So in the unidirectional, all values are written horizontally with a break in the dimension line. In the aligned system, all the values are written above the line without a break, whether it is internal or external, whether it is angular or linear. So with these examples, again we can see number of sketches with showing those examples. Okay, one more slide, somehow I don't know it's missing. Okay, we'll see that. Okay, now the types of dimensioning. We have seen systems, now types. Okay, what are the types of dimensioning? As I told you, for different reasons, different contexts, ఆ అవసరానికి అలా వేస్తేనే బాగుంటుంది, ఈ అవసరానికి ఇలా వేస్తే బాగుంటుంది అనే విధంగా మనకి టైప్స్ ఉన్నాయి. హ్యావ్ ఎ కర్సరీ లుక్ ఎట్ ఆల్ దీస్ టైప్స్ ఫస్ట్. The name itself suggests you need not by heart anything. The name itself tells the layout. You see that? Please observe, all of you. Okay, chain dimensioning, you see. Suppose all the dimensions, the object is such that all the dimensions can be written only on a line, single line, or all the dimension lines are in a single line, then you go with chain dimensioning. You see, it's like a chain. All the dimension lines are in a series, one next to the other along a length. That is chain dimensioning. This is horizontal ga ikkada undi, vertical ga kuda ila undi. Adi now ఈ సిస్టమ్ ఏంటి? ఇది చైన్ డైమెన్షనింగే. కానీ ఏ సిస్టంలో వేసాము అంటే మీరు ఆన్సర్ ఏమి ఇస్తారు? ఇది చైన్ డైమెన్షనింగే, కానీ చైన్ డైమెన్షనింగే కానీ ఇది యూనిడైరెక్షనల్ aligned అంటే వాట్ ఈజ్ యువర్ ఆన్సర్? సో వాట్ ఈజ్ ది ఆన్సర్? యూనిడైరెక్షనల్ అయితే అన్నీ హారిజాంటల్గానే ఉండాలి. హారిజాంటల్గా ఉన్నాయి కానీ వర్టికల్ లైన్కి వర్టికల్గా ఉన్నాయి. అంతేకాకుండా యూనిడైరెక్షనల్ అయితే మధ్యలో బ్రేక్ ఇచ్చి రావాలి, ఇక్కడ బ్రేక్ లేదు కదా. దేర్ ఫార్ లైన్ ఎలా ఉంటే రైటింగ్ కూడా అలా ఉంది కాబట్టి అది అలైన్డ్ సిస్టమ్. సో నౌ యూ కెన్ సీ. సో చైన్డ్ టైప్లో అయితే చైన్ డైమెన్షనింగ్, సిస్టంలో అయితే అలైన్డ్ సిస్టమ్ అదనమాట. సేమ్ కెన్ బి రిటర్న్ ఈవెన్ ఇన్ ది యూనిడైరెక్షనల్ సిస్టమ్, అందులో డౌట్ ఏం లేదు. దెన్ parallel dimensioning or datum or baseline dimensioning. All dimensions start from one point. In that case, it is called parallel dimensioning. That is, for example, అన్నీ కూడా ఒకే పాయింట్ నుంచి మన మెజర్మెంట్స్ మార్కింగ్ కంఫర్ట్ కోసం ఒకసారి అలా ఇస్తాం అన్నమాట. ఇక్కడ చూడండి అన్నీ ఇలా ఇచ్చాం అన్నమాట డైమెన్షన్స్. అన్ని డైమెన్షన్స్ కూడా ఒక కామన్ లైన్ నుంచి స్టార్ట్ అవుతున్నాయి కదా, ఇక్కడ హారిజాంటల్గా, ఇక్కడ వర్టికల్గా. మళ్ళీ ఇది చెప్పండి, ఇవి కామన్గా ఉన్నాయి. ఆల్ ది డైమెన్షన్ లైన్స్ ఆర్ ప్యారలల్ ఆర్ నాట్? ఇస్ ఇట్ నాట్ సో? దర్ ఆల్ ప్యారలల్. ఓకే, హియర్ ఆర్ హియర్. అగైన్, ఇస్ ఇట్ ఇన్ అలైన్డ్ ఆర్ యూనిడైరెక్షనల్? హారిజాంటల్, 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 అండ్ విత్ ఎ బ్రేక్. సో దిస్ ఈస్ యూనిడైరెక్షనల్లో ప్యారలల్ టైప్, యూనిడైరెక్షనల్ సిస్టమ్ ప్యారలల్ టైప్. అలా. సో ఆబ్జెక్టివ్స్లో క్వశ్చన్స్ అలాగే వస్తాయి. ఒక స్కెచ్ ఇచ్చి జస్ట్ జంబుల్ చేస్తూ వర్డ్స్ కన్ఫ్యూజింగ్గా ఇస్తారు. దాట్ వీ షుడ్ బి ఏబుల్ టు క్యాచ్, కాన్సెప్ట్ పట్టుకోవాలన్నమాట. మనం చాలామందికి సరిగా ప్రిపేర్ అవ్వకపోతే ఆప్షన్స్ వెతుక్కుని ఆన్సర్ పెడుతుంటారు. కుదరదండి. క్వశ్చన్ చదివాక మనం ఆన్సర్ ఏంటో టప్మని ముందు మైండ్లో పెట్టుకుని ఆన్సర్ తోటి ఆప్షన్స్ తీసుకుంటే మిస్టేక్ లేకుండా కాన్ఫిడెంట్గా ఆన్సర్ చేయడానికి ఇవన్నీ ఆలోచించండి అని చెప్తున్నాను. అదే ఇప్పుడు నెక్స్ట్ టైప్ ప్యారలల్ డైమెన్షనింగ్, తర్వాత ప్రోగ్రెసివ్ డైమెన్షనింగ్. ఏంటంటే ఈ ప్యారలల్ డైమెన్షనింగ్లోనే డైమెన్షన్ లైన్స్ అన్నీ కలిపి సింగిల్ లైన్లో వచ్చేస్తే, యు సీ దిస్ హియర్ లైక్ దిస్, దట్ ఈస్ కాల్డ్ ప్రోగ్రెసివ్ డైమెన్షనింగ్. బికాస్ ఇన్ ది ప్రోగ్రెసివ్ డైమెన్షనింగ్ యూ హ్యావ్ ఆల్ ది వాల్యూస్ లైక్ ఏ చైనేజ్. చైనేజ్ అంటే ఏంటి? ఒక బిగినింగ్ పాయింట్ నుంచి ఆ పాయింట్ దాకా ఎంత డిస్టెన్స్ ఉంది, ప్రతిదీ కూడా బిగినింగ్ పాయింట్ నుంచే డిస్టెన్స్ ఉంటుంది. అది చైనేజ్ అంటాం కదా. అట్లా మ్యాప్ చేస్తే ప్రోగ్రెసివ్గా వాల్యూస్ ఇంక్రీజ్ అవుతాయి. కాబట్టి సి దిస్ ఈస్ 20 ప్లస్ అనదర్ 20 ఇఫ్ యూ పుట్ you'll get 20 plus 20 40 60. So all these are from a common point. This is called progress. And the dimension lines, you can, the arrowheads you can see, they are only in one direction except in the beginning. This is a chance in objective questions. So నెంబర్ ఆఫ్ డైమెన్షన్ లైన్స్ మనం వేస్తున్నప్పుడు ఓన్లీ వన్ డైరెక్షన్లోనే యారో హెడ్స్ ఉంది. ఏ టైప్ ఏది అంటే ఎక్సెప్ట్ ది బిగినింగ్ యారో హెడ్, ఆల్ అదర్ యారో హెడ్స్ ఆర్ ఇన్ ఓన్లీ వన్ డైరెక్షన్. దెర్ ఇస్ నో రివర్స్ యారో హెడ్, రైట్? సారీ, దట్ ఈస్ ప్రోగ్రెసివ్ డైమెన్షనింగ్. ఓకే, అండ్ దెన్ కంబైన్డ్ డైమెన్షన్. సమ్టైమ్స్ వీ డోంట్ హ్యావ్ space for all these things. Sometimes based on the figure you may have to give 2-3 referencings like that. For example, here there are several objects coming, therefore here some details on this side, some details on that side, in which case you have different dimensional lines starting at different points, ending at different points, parallel anyway, but similarly in the vertical also. Now also this example you can say whether it is in aligned or unidirectional. Aligned or unidirectional? Yes, it is aligned, because for the verticals we have written from bottom to top. So like that. Okay, so this is a combined dimensioning. Sorry, okay, this is the example for what? Combined dimensioning. Of course, equal dimensioning, same sketch it will come because of the space. You can understand if there is a repeated values, we will put, for example, here I will just show you some repeated values are there. No, all values are same. In that case, we put just to give better readability, we will put only to give a better readability. Here we put some dimensions, say 25. Same value is there, so you put is equal to. Instead of writing 25 number of times, we will just put equal to. That means all the dimensions are same. So that type of dimensioning is called equal dimensioning, and this is only to raise the understanding level. So quick readability. See, this is what different contexts, different types have evolved like that. So like that you can see equal dimensioning, that is the example, okay. And then the other, you can see in the next slide, the angular dimensions in both the systems and the coordinate dimensioning. Angular dimensioning means you are showing the angles. You are showing the angles. You see, if it is an aligned unidirectional system, all the angles are shown by giving a break on the arc. This arc should be drawn such that when you are showing the angle, that is between two lines, is it not so? These lines will intersect at a point. For example, there are a number of radial lines here. All are intersecting at this point. So this arc should be with the center as this and radius as this, such that మీరు ఎక్కడ డైమెన్షన్ వేయాలనుకుంటున్నారో అక్కడ డిస్టెన్స్కి రేడియస్ తీసుకుని ఆర్క్ కొట్టాలి. అది అందువల్ల ఒకే పాయింట్లో చూపించాను. ఒకే పాయింట్లో చూపించాలని లేదు, ఆర్క్ యొక్క కర్వేచరు మనకి నీట్గా కనపడుతుంది. అలా ఉండడం వల్ల ఏమవుతుందంటే రేడియల్ లైన్కి ఏరో హెడ్ డైమెన్షన్ లైన్ అన్నీ కూడా పర్పెండిక్యులర్గా వచ్చి నీట్గా కనపడతాయి కాబట్టి అలా వేస్తే బాగుంటుంది. అది ఓకే. సో దట్ యూ కెన్ అండర్స్టాండ్ దట్. సో డిఫరెంట్ యాంగిల్స్ ఆర్ షోన్, బట్ because it is unidirectional system, all the values are written horizontally, whereas same angular dimensions if you want to show in the aligned system, you can see along this, along this, along this, along this, above line. See the difference between this and this, okay? Above line, above line. Similarly, this and this. So like that, there are several examples you can see, okay. Yeah. For this direction, I am putting 60 degrees in this way. For this direction, I am putting 30 degrees in this way. Again, these two you see, clockwise, anti-clockwise directions. Like that, that system is our aligned system, okay. And then here, dimensioning by coordinates. This is good for our CAD/CAM jobs, for easily feeding things. You know what are coordinates? We take a reference point, take an origin point, so that we will establish an x-axis and a y-axis. The two coordinate axes, is it not so? Horizontal x-axis, vertical y-axis, right? These two coordinate axes. With reference to those coordinate axes, with the origin as the reference point for measurement, we'll locate different objects in the drawing. For example, there are some boreholes on this plate drilled with different numbers are there, and their diameters are also different. Accordingly, we'll give numbers for those objects. For each number, we'll give its x coordinate and y coordinate. For example, number 3 is here, here number 3. For number 3, its x coordinate is 60, means what? From this vertical line, the distance here up to this, that is 60. Similarly, that is x value. Similarly, the y coordinate for this point, that is from here, this height. Y coordinate is how much it is? 120. You now understand? This is all, it's not a big new thing, all can understand well. So we will need a table of coordinates to accompany the drawing. Without this table of coordinates and designation, you cannot give that, okay? For CAD/CAM words and all, such things are suitable. Then, so we have seen some 7 types of dimensioning and 2 systems of dimensioning, and you can also see, before we go to the next chapter, we'll see this and have a small break. What is that? Indications, that is shape or size notations. See, dimensioning is to give quick readability for better understanding with least number of values, etc. For that, these things were given by the code. What are they? What are they? You can see it is written R15, R10. That means what? Radius value 10. You see, R tells what? Radius. Similarly, phi tells what? Diameter. Okay. Phi is diameter. Where is phi? You can see some diameter. Yes, phi. See, phi 30, phi 40. So you should write like phi 50. That is correct. But if you write 50 dia, we may say, but we should not tell like this. We should write like this. We should not write like this. We may call, that's a different issue. But we should always put the diameter symbol or radius symbol first and then put the numerical value. This may be a big question. Please understand that. అంటే పెద్ద పట్టించుకోకుండా చేసేస్తుంటాం కాబట్టి మిస్టేక్స్ వస్తూ ఉంటాయి. అలవాటే కాబట్టి కరెక్ట్ అనుకోకూడదు. కోడ్ ఏం చెప్పిందో చూడాలి అది. సో దట్స్ అబౌట్ diameter, radius. Similarly, square. Some shape, for example, here it is shown for this part some 40 square. See, numerical value preceded by the symbol, that is the rule. Okay, or symbol followed by the dimension numerical value, that is the rule. Okay, so you can see this tells that if you see from this direction, this will have a shape like this. Okay, that's all. Whereas for this, if you see from this direction, this is a circular one. Here dia 30, that means this object is something like some rod. Similarly, from this side I will show you. This object is something like this. Okay, like this. So diameters in one elevation or some plan, we have only 2 dimensions, not the 3 dimensions. So such things you can see like that. Similarly, radius, and then radius square we have seen. Now spherical dia and spherical radius. The symbols are S, phi and SR. For example, here it is written here. Here spherical radius, and this is spherical radius. That means inside it is not a cylindrical hole, it is like a spherical hole. So if you cut like this, there also the hole will be like this. The object will be like this. Whereas that is if you cut like this and see in this direction, you will have like that. Suppose if this is a cylindrical one, no? Spherical diameter, spherical radius, whereas it is a cylindrical one, if you cut like this and see, you will see the drawing in this form. Because it is spherical all round, no? It is spherical all round. If you cut here and see, you will see another same radius. If at all, if it is a cylindrical one, you don't show like that, you simply say radius. In that case, the continuous drill hole will be like that. If you see in the side cross section, you will have that. So similarly, spherical radius or spherical diameter. So these are the symbols. Okay. Similarly, there are other indicators like tolerances, finishes, etc. But there is we cannot go on explaining the code. Okay. So this is how you can understand different aspects of dimensioning, wherein we have studied the different systems of dimensioning and then types of dimensioning, in which for different contexts different types have evolved. If you understand in what context what is useful, you can easily remember. Okay, so uh, if the questions are there, you have to understand how the question is, the sentence is describing the context, accordingly think and say what type of dimensioning it is. Or if the system, if the sketch is given, you can easily identify that. The trouble comes here only if the description is there. English medium issues కొన్ని ఒక్కసారి ఇబ్బంది పడతారు అందుకని చెప్తున్నాను. ఓకే రైట్. ఓకే I think we can have a small break. Next we will be discussing about this lines and planes. Okay. Construction of geometry figures, this we will discuss after some 5 minutes break, right? Thank you. Right. Welcome back, friends. So, we had a discussion on dimensioning, etc. Now, we will go with next topic, that is construction of geometric figures. What is a geometric figure? If you can define its boundaries in a proper way, that's a geometric figure, and there are certain entities like a point, line, and plane, solid, like that. No, a point is a single location entity. A line is a length joining two points. Similarly, if there is a region bounded by certain lines, it's a closed figure. But instead of showing in a haphazard manner, if we can show in a regular way with certain interrelationship between the boundaries, etc., that's a regular figure. All of us know these things, like for example, here there are three regions shown bounded by two lines. This region is one thing, this region is one thing, this region, this space is another thing. Here, these regions are bound by two lines. Such a situation we call angle. Okay, angle here, this line is inclined at 90 degrees, so it's a right angle. If some angle is more than 90 degrees, okay, if some angle theta is more than 90 degrees, we call it obtuse angle. If that value of theta is less than 90 degrees, it is called acute angle. Only three, only three, yeah, there are other things also. We generally only discuss these things. There are other terms like zero angle. If these two lines coincide, if I go on reducing, for example here, if I go on reducing this value theta to 0, both lines coincide, no? Same way, then it's a zero angle. Zero angle. Similarly, if I go on raising this value, then this line will be in line with that. In line with that. Then this becomes 180 degrees. Okay, in line with that. If I go on increasing this value 180 degrees, in line with that, then it is a straight angle. Right angle is 90 degrees, zero angle is 0, and straight angle is 180 degrees. Straight angle, that is called. Okay. So like that. Similarly, there are other terms like supplementary angle and complementary angle. Okay. So like that, something which is part of 90 degrees. Suppose you, like that, there are so many other things. Anyway, let us finish quickly. Today we have to also discuss some questions. Right. So, you know, these are all plane figures. Right from school days you are learning. There is nothing new for you. Just for in the exam point of view, a small brushing, refreshing knowledge with certain exam point of view discussions. Okay. So, if what is an equilateral triangle? These are all triangles, right? What are the types? A scalene triangle. Scalene triangle. Scalene means the three sides are not equal. Hence, three angles are not equal. If one of the angles is 90 degrees, then it is a right angle triangle. Similarly, if all the sides are equal, it is isosceles triangle. If only two sides are equal, then is equilateral triangle. So an equilateral triangle will have one axis of symmetry. An isosceles angle triangle will have 3 axes of symmetry. This we discussed, you remember? Whereas these angles do not have any axis of symmetry unless some 2 sides are equal, then it becomes again isosceles triangle. Okay. So what are triangles then? Triangles are closed figures with straight lines as boundaries. So a triangle will have 3 vertices, that is 3 corners and 3 lines. And we know different terms like square, rectangle, rhombus, rhomboid, like that. Trapezium, trapezoid, like that. But they are all under the class of parallelograms. Generally, we used to call only this as, in the school level, this as parallelogram. But for the parallelogram, if all the sides are equal, that becomes rhombus. And for the rhombus, if all the angles are equal, it is the square. And for the rhomboid, if angles are equal, then 2 opposite sides are equal individually, that becomes a rectangle. Thus, a rhomboid can be described with certain conditions either as a rhombus or a rectangle or a square. So on this you may have questions. Individually you may know, but how to describe it, conditions, right? And one important property is here, if you see the diagonals, only for 2 things the diagonals intersect at right angles, 90 degrees. What are those 2? See, the square. For the square, the diagonals intersect at right angles. Is it not so? Similarly, for the rhombus also, the diagonals intersect at right angles. This is one of the questions in the recent examinations. Okay? So, the diagonals intersect at right angles for rhombus only అని చెప్పి మిగతా కూడా ఇవ్వచ్చు, స్క్వేర్ కూడా ఇవ్వచ్చు. అప్పుడు కరెక్ట్ ఆన్సర్ ఏమవుతుంది? స్క్వేర్ కూడా ఉంటే అక్కడ ది రైట్ యాంగిల్స్ ఇంటర్సెక్ట్ ఫర్ బోత్ రాంబస్ అండ్ స్క్వేర్ అన్నది కరెక్ట్ ఆన్సర్ అవుతుంది. అట్లా అది నేను చెప్పేది. ఓకే. అండ్ ట్రెపిజంకి ట్రెపిజాయిడ్కి ఏంటి తేడా? ట్రెపిజాయిడ్ అన్నప్పుడు అట్లీస్ట్ 2 sides, they may be longer or shorter, no issue, they are parallel. If others, there is no set parallel, then we call trapezium, right? And then if it is 3 lines, the closed figure is a triangle. If there are 4, it may be a parallelogram, square, rectangle, like that. And if there are more than 4, that too, all the lines are equal and hence all the angles are equal, intersecting angles. Such things are called polygons. When the things are with symmetry and equal lengths, they are called regular polygons. Regular polygons. Okay. We only discuss regular polygons, right? Okay. What are if the number is 5, that is 5 corners, 5 sides, 5 pentagon, 6, hexagon, 7 heptagon, sometimes they write septagon అని కూడా రాస్తున్నారు. Then 8, like our clock, 8. Wall clock, right? Octagon, 9 nanogon, 10 decagon, 11 dodecagon, like that. Anyway, they're all Latin words or some other words. So we will be having few discussions about the geometrical similarities, construction issues, and the combination with circle, all these things. Here, among the closed figures, if this number goes to infinity, what is the result? Result is a circle. So, the circle can be viewed or expressed as a polygon with infinite number of sides and also infinite number of axes of symmetry. And what about the axis of symmetry for these things? Whatever is the number of sides is the number of corners. So same is the axis of symmetry. Okay. Now, this is one particular slide wherein you can comfortably answer so many questions or expect so many questions if the topic is classified as per our syllabus as geometric, construction of geometric figures. Okay. Now what I have shown here, you can see, is a regular polygon, that is a hexagon. Okay. It is a hexagon. Okay. Now this hexagon okay, because the number of sides is 6, no? So it is a hexagon. Okay. Right. Identify the properties and write the relationships. Take the number of sides as n. See, hexagon I am showing you as an example to describe the regular polygons and their properties. Okay. So, what are those things? We will start with. You can see here what is the sketch. Let me first describe you. I have drawn a regular hexagon. Then, with that regular hexagon, I have drawn two circles. One is an internal circle which is tangential to the sides. You know meaning of tangent, okay? Which is tangential to the sides, okay? Right? So, this internal circle is tangential to the sides, okay? And then another circle outside this red color dots, right? That is passing through all the 6 corners. So, hexagon ki బయట ఒక సర్కిల్ ఉందండి, it passes through the points. లోపల ఒక సర్కిల్ ఉంది, అదేంటి, it passes through points which are midpoints of the sides and hence also it is tangential to sides at those points. Okay. Therefore, if you want to understand the radii of these circles, you just take one center of the circle and join the sides and identify this triangle. Like that there are 6 triangles making the hexagon, or n triangles if it is a polygon, such that it is an isosceles triangle first thing. For the hexagon it is an equilateral triangle again, is it not so? For the hexagon it is an equilateral triangle, and the triangle's length, this length is the radius or the distance from the center to one of the corners. That capital R is the radius of the outer circle, and that circle is called circumscribing circle. It is circumscribing, it is above the hexagon, it is called circumscribing circle. And whereas if you see the distance from the center to the midpoint here, see this distance, small r, this blue color circle, it is inside the polygon, in this case hexagon, inside the hexagon, that circle is inscribed circle. So, there is an inscribed circle and there is another circumscribed circle. Okay. Right. Now, let us see the properties. What is the number of axes of symmetry? In this case, n here is 6 here, okay. Okay. Then central angle of the side. What is the central angle of the side? The side makes an angle at the center, that is theta. That theta, okay, that theta becomes how many? If there are n sides, all the sides, each side will make an angle theta there, is it not so? So that theta, like that, 6 sides together will cover all the central angles together. Therefore, like this there are 6 thetas here, total this becomes 360 degrees. Okay, like that. How much will be then each? If there is a polygon of n sides, central angle of each side becomes what? 360 divided by n. Yes, here it is 6, so therefore 360 by 6, that is 60 degrees. So what is the formula for the number of angles, number of axes of symmetry? N. Similarly, central angle of a side is, that is angle made by the side at the center of the polygon, becomes 360 by n. That is the formula. Then interior angle. What is the interior angle? Here it is shown as beta. The central angle is shown as theta. The interior angle, that is the angle made in the inside of the polygon between the sides, that inside. Okay, that is beta. What is that beta? That beta is interior angle. How you get that? That you can get, there is a formula, 2n minus 4 right angles to n plus right angles. Like that we have formulae in the geometry, right? 2n minus 4 into 90, you will get that. You can also prove it easily. Okay. So interior angle becomes 2n minus 4 into 90 degrees becomes interior angle. Exterior angle, 2n plus 4 into 90 degrees. So our exterior angle is nothing but 360 minus beta. So that you will get that. Deflected angle. Deflected angle means here, whatever is theta here, same will be the deflected angle. Automatically, this will be equal to that. Okay. So same thing, you will get that. This line in the polygon, it is going like this. Next, it deviates from this direction to this direction. So this is deflected angle. It is. That's how. Okay. Then deflection angle. Sum of interior angles. What is sum of interior angle? What is interior angle? Beta. Okay. So sum of, this is sum, of course, n into beta, of course, right. So from this you will get that. For n into beta is not beta, n into beta is that. Okay. So sum of interior angles is given by this value. From this you can get the beta value. So sum of interior angles is 2n minus 4 into 90 degrees. You will get that. Similarly, exterior angle plus 4 into 90 degrees. Deflected angles. See, all these lines come back to same position. Therefore, 360 degrees. Alpha becomes all the alpha. That is sum of deflected angles. N into alpha is nothing but n into theta. So alpha and theta are same. Alpha and theta are same. Value wise they are same. For example, hexagon, you see, we will know that for hexagon this is 60 degrees. This is also 60 degrees. Is it not so? Therefore 180 minus 60, this is 120 degrees. So you can just try like that. You will get all those things. Similarly, perimeter. How you get perimeter? If the length of the side is, say, x. What is perimeter? Chuttukolata. Enta avutundandi? N into x is perimeter. Areas of the hexagon, circle, haunch and segment. There are terms like haunch and segment. You can get them. Just I will explain to you here. For example, area of the hexagon. That is, how you get the area of the hexagon? Or if you know the area of one triangle into n, you will get area of the polygon. So to know the area of this, when you know the central angle, you can calculate the height as, if this is x, you know, this height, how you get that? If this is x by 2, no? This distance is what? X by 2. And in the central angle is theta. So this angle is theta by 2. And this is from this x by 2 and this theta, for this theta by 2, x by 2 is opposite and r is hypotenuse. Therefore, Sin theta by 2 is opposite x by 2 by r. From that you can get, because you know x and theta, you can get the r. Okay. Similarly, with the relationship of opposite and height, tan theta relationship use chesi, you can determine this height of the triangle. So area of the triangle is half BH. So we can determine the values of r and that is corner radius r and this height of each triangle, from that theta by 2 and x by 2 using sin theta by 2 and tan theta by 2. From them whatever you want you can calculate, especially the area half BH, like that you can calculate for each triangle into number of triangles will give you the area of the hexagon or polygon. Now the other things, areas of the circle. Once you know the radius, you can know the area of the circle. For example, for the circumscribing circle, capital R we have seen, is it not so? How you get capital R? Capital R is nothing but x by 2 sin theta by 2, is it not so? So that is the capital R. Pi r square, you will get the area of the circumscribing circle. Similarly, small r value is what? What is tan theta by 2? Opposite by adjacent. So this adjacent, that is height of the triangle, is equal to x by 2 by tan theta by 2 or x cot theta by 2. When you get this value as x cot theta by 2, that radius is the radius of the inscribed circle. Therefore, you can get pi r square, small r value if you put, you get the area of the inner circle. Okay. So how to get the areas of the circle? From that equation, pi r square or pi this capital R square. Okay, this or that, we can get that. And then haunch and segment. What is haunch and what is segment? You see, here I am showing you this area is segment. Okay. Similarly, this area is haunch portion. Okay. This area is haunch portion. That area is segment portion. How you get segment area? There are n sectors. Get the area of one sector, deduct the area of one triangle, you get the segment area. Okay, we have seen the formula for circle. Divided by n will give you sector area. From that deduct the triangle area, you get the segment area. Okay. Do that exercise so that you can remember well and answer the question quickly if it is through these lines. Instead of practicing in the examination time, just try with one example. You can also have a check by combination of all these things, totals you will get that. Okay. And then how you get the haunch area in the same manner, you can see. How you get the haunch area? You see, from this triangle, deduct the sector area of the inscribed circle, the balance is haunch area. Is it not so? Like that, see, this haunch area, you can see as the, you can see that, no? Here I am drawing another triangle, you see. Okay, I will just remove the other things so that the last one you can understand better. You see, haunch, I will explain here. So, this radius, no, this is the circle, okay. This is the triangle. Take the area of this triangle A1, from that deduct the area of this sector. What is the radius? Small r is the radius. So, what is that sector area? Pi small r square divided by number of sectors, that is n. You will get the sector area that you deduct from the triangle area, which already we have discussed. Then what you are getting will be the sum of this area and this area. These two are haunch portions together, one haunch. Okay, like that. So you must be definitely, you must have heard already, వినే ఉంటారు. ఏంటి విని ఉంటారు మీరు? పాలిగన్ విన్నారు, ఇన్స్క్రైబ్డ్ సర్కిల్ విన్నారు, సర్కమ్స్క్రైబ్డ్ సర్కిల్ విన్నారు, డిఫ్లెక్టెడ్ యాంగిల్ తెలుసు, ఇంటీరియర్ యాంగిల్ తెలుసు, సమ్ ఆఫ్ ఇంటీరియర్ యాంగిల్స్, ఎక్స్టీరియర్ యాంగిల్స్, ఇవన్నీ మీరు చదివినవే. బట్ కొంచెం ముందుకు వెళ్తే ఎగ్జామినేషన్ పాయింట్ ఆఫ్ వ్యూలో ఇవి అడిగే ఛాన్స్ ఉంది కాబట్టి అవి ఎలా సాల్వ్ చేయాలి అన్నది ఈ స్కెచ్ మీకు చెప్తుంది. సో జస్ట్ అప్లై, ఎక్స్టెండ్ యువర్ జామెట్రీ. సో కన్స్ట్రక్షన్ ఆఫ్ క్లోజ్డ్ ఫిగర్స్ ఈజ్ వాట్ ఈస్ గివెన్ ఫర్ అవర్ construction of geometric figures is what is given in our syllabus. So for that I have prepared this. Okay, so then you can see the other things like the what you call regular polygons and all, but I think tomorrow you also had one exam. I think better we close. So after discussing with the administration, I wish I can take 10 minutes or 15 minutes from tomorrow onwards extra, so that we'll come to the end, right? Okay, so we'll tomorrow continue our discussion on the polygons, how to construct the polygons, etc. And to, these are all examples in the pentagon, US military headquarters. Okay, so similar your civil engineering building shapes, etc., of polygons, etc. Okay, and then this is one exercise where I insist my students to try your skill levels, how accurate is your understanding levels. If you see, for that you can inscribe 7 circles of equal radius in a hexagon through this construction, a very self-explanatory construction. You take one triangle of the hexagon, then take the intersection of the medians, then take this distance as the radius. With that radius in each triangle, you construct the circle such that with the same radius, you will have another circle. This is the real challenge always. It's a self-test for the skill, but in the examination we are not getting skill test. We are getting knowledge tests only, of course, but it's a possible question. How much is the, like that even in your lower classes also you must have seen a question on this. Some 7 coins are placed inside some hexagon. What is the area, like that? So that all those things you can see in the what you call geometrical constructions or other geometry problems. Okay. Now just because before closing I have shown you the dimensions. What is the system of dimensioning used here? Here it is, because it line break is given, so it is system is same horizontal with a break. It is unidirectional system, and here also with a break it is given, angular dimension also same as unidirectional system. When you draw a figure, you should follow throughout in the drawing sheet, not only figure, either unidirectional system or aligned system, but never a combination. That to explain you that point, just I have stopped here. So next we'll have a discussion on orthographic projections. I just wanted to cover that also, but we could only cover up to this much in this 1.5 hour with only one break. So I have to discuss with the academy heads regarding taking some more time so that we can finish quickly. Okay, you can also give your suggestions in the comments. You are welcome, so that we together will win. Okay, thank you all the best. Tomorrow some of you are having examination. I wish you all the best for the Service Commission examination. Thank you. Good night.